All right, so I'm probably gonna record two videos today. One at now it's 3 p.m. and then record another one later in the night after the gym or something. So yeah, I mean, I can imagine honestly next week I'm still probably gonna be doing these three questions. I think I need more time on them, and then after that, I'll definitely do linked list questions next. Let me open up auto draw. Uh, all right. All right, so basically, which question should we do? Average of levels. So the ones we've been doing so far, DFS questions. Let's see, lowest common ancestor. Diameter of binary tree. Diameter of binary tree. All right, let's try average of levels. Let's just try this one here. Fuck it. I don't want to look at the solution, so out you go. So, given a non-empty binary tree, return the average value of nodes on each level in the form of an array. So this is clearly a DFS question. I'm sorry, a BFS question, because we're seeing the average value of nodes on the level. So we're, level traversal over here. The average value of the nodes on level 0 is 3. On level 1 is 14.5. Level 2 is 11. Hence, so we just build an array. All right, so first things first, obviously we have our output. We have our output here. Obviously, that's where shit's going to go into. So this is a BFS question, and as it being a BFS question, it will involve some extra data structure, such as a queue. So we can build our queue, and we can use the built-in deck into Python. I believe internally this is a, I'm spelling this wrong. Deck. How the fuck do I spell deck? I know internally a deck is a doubly linked list. Deck systems. Deck. I spelled that right, didn't I? DEQUE. Wait, what the fuck came up when I just searched deck there? Digital binary search tree. Decorum. Thought I searched some weird shit. I was like, what? Anyway, deck. Deck. Wait, what? Am I retarded? Deck. The key. God damn. Alright. The fact it's not going blue makes me think it's not even noticing. Okay, whatever. I got Python deck. I'm not used to type it in this position. I also keep looking out of the keyboard because the mic's in the way. I keep thinking I'm pressing the wrong things. Deck. Alright, yeah, deck. So we got our deck, So basically the idea is that when we go down to a level, we add this to the queue. So, well, the first thing, of course, is checking that if you, of course, want to initially check that the element, the root is, well, a value, right? Sorry, it's valid. It's not empty, so it's not null. So we obviously have if root. I'm pretty sure BFS questions are better handled iteratively, by the way. I don't think you need to do this. I don't know, I don't think I've done a recursive BFS question before. Well, I haven't done it in recursively. I think I've always done them iteratively. But so we want to check that the root is valid, right? That it's not null. We, of course, well, yeah, if we do that, then, well, first, we just want to add the root to it, right? So the first element of the queue becomes root, right? Is that how you add things? Is this valid? Is that how you add things to a deck? How to add to deck. Python. Well, I don't want to actually pan. I just want to do the first. Okay, yeah, that makes sense to me. You just say, okay, yeah, that makes sense. Well, actually, let me just print Q to make sure I'm not crazy here. Cause I'm an evil nigga, I deserve to die in pain. This is out of range. Bakraya, kanraya, bakraya, kanraya. Am I making this right? Q. Wait, what? All right, you know what? Q dot append root. Q dot append the root. All right, cool. All right, the whole thing's added to it. Cool. All right, so basically, yeah, if the root is valid, then we want to add the we essentially want to add the all right, hang on, let me think. So if we're at the root, we're at 3, we want to add 9 and 20, right? So we want to say if root, cool, but also if well, yeah, I mean, we want to add the left and the right? So q dot append q dot append q dot append q dot append root dot left. No, root. Just root. Can we? Oh wait, I'm guessing we can do this recursively. Hang on. If root, then q dot append it. Hang on, we append this to the queue, so we want to append the next element in the queue. So we want to append left, then append right, then append left, then append right? So we append, so if root is valid, right? If root is valid, then append root dot left, append root dot right, yeah? Append this shit. So now it should be, this has, the first thing in it, right? But we kind of want to hop to the next level, right? We want to hop to the next level. If root is valid, right? If root is valid, so we add, root's already in it, right? Then we append the left, boom. So now we have 3, 9, and 20. So obviously output at this point is root dot val? No, actually no way. Q dot append root. Q dot append root. Yeah, output is output should be root dot val. Root dot val. At this point, and then q dot append root dot left, q dot append root dot right. So we append the left, we append the right, and then we want to go down to the next level. So every time we do that, we want to pop these, don't we? Well, okay, we have this kind of, you can imagine a current, current Q or whatever. So we have, well, no, don't need that actually. We have Q, which is root, Q dot append left, Q dot append right. Then you can see Q dot, hang on, let me think. Q dot, so we have our Q, and we append the root to it. Our output is just that value. Then if root, Q dot append root dot left, Q dot append root dot right. Append the left, append the right. And of course the left is also another tree, which we can go into. So the left has a left, the right has right, and all that shit. So we have Q dot append. So we can say while Q, so while the Q is valid, if root, then append left, append right? append left, append right. So now our queue should have left and right in it, right? Should have 3, 9, and 20. Well, the average over here should already be calculated, right? So the average, well, the average is the value there, so. Yeah, okay. So now our queue should have 9 and 20 in it, right? Well, while queue, so we should pop. So node equals q.pop left, which is 3 at the start, right? This is our current level equals node blah blah. So we have then current level dot append node. I mean, yeah, at the end, let's just print current level, see what's outputting. We have node equals pop dot left, the current level dot append node, q dot append left, q dot append right. But if it's null though, so would we also have to check? Would we also have to check if node equals q dot pop left? Well, if root node dot equals if root, well, my pen, I don't think I need that pen. So current level node equals 3, let's say initially, then we add it. What if I were to say while q, well, I think I can check up here if root, and then here I might need to check if root dot left and root, if left, or yeah, if left append if root dot right, then append. So now we have 9 and 20. Node equals q dot pop left, current level equals append, and then print the current level. Wait, what? It's added. Oh shit, that's right, it's added. Leave out the value. Here we're popping node, but we need to append node dot val. We append node dot val. So what's over if root dot left? So sorry, if node dot left. If node dot left, we append node dot left dot value. If node dot right, we append node dot right dot value. Oh no, wait, shit, I'm adding this to the queue. Whoops. Oh no, yeah, no. Wait, current level dot append not dot val. It object has no attribute val. This is the node. Node equals q dot pop left. Initially we have root. Oh yes, that's right. No, new node equals this. It has no option val. If node dot left, q dot append. Wait, if node dot left, shouldn't that be if root dot left? If node dot left, if root dot left, if root dot left, then q dot append. Well, no, because we want to get to the current, so this makes sense. We have our current level, and then we have node equals q dot pop left, current level dot append node dot val, current level dot append node dot val. If root, it has no value. Node dot val, node equals q dot. Okay. This is the problem here. Print node. Print node. It's for some reason the value. Or is it? Hang on. Print node. Print node. Current level not append. Print the node. This node has. Yes, this node has their values. You know, blah blah blah. But then why is it just 9 at the end? While q. Probably could be up here actually. We're appending. We see q, so we have q equals dec. Our output is this. Our output is now this, right? Our output initially is 3 because our output initially, of course, is 3 because we have root.val in it. Yes, our output is 3 initially. That's what we want. That should be an output. That's correct. So q.append root output.append. Well, the thing is, we appended root over here. Why? Why would we do that? Why would we append root to it? We should only append over here, no? Okay. So print node. Print just to be printing something now. Well, actually, no, we do need to append because this will never run. This will never run then. If q has nothing in it, it will never run. So q equals root. And then the output is this. So if I run that again, they should be able to initialize. The list has no object. Oh wait, did I convert it to a root here? Append left. I mean, it doesn't really matter which way I append it. It's like there's no items there initially anyway. It's been 17 minutes. So this is being added. Then we got 3. Print node, huh? Print current level. We don't need that in it. You're saying this int object. What int object? Because output has. But I'm not doing anything with output here. This is really, we don't like this is not doing anything at the moment. How was there an int object in here? I'm appending the whole root, which is literally the whole recursive tree. You're telling me that 9. Where is this 9 coming from? Where the fuck does 9 come from? Is that because the value is added here instead of the root? If node dot left. Oh, I see. If node dot left, then append node dot left. If node dot right, then append node dot right. But here we're appending node dot value. Okay, so this will work. All right, cool. That's perfect. So now we have the entire recursive tree leveled out in the current level. So if every time we add the value to current level, every time we add the current value to level, right? So when we go through it once, we have our level, right? So essentially what needs to happen is if root current level equals this, we need to add this to output. So say output dot append current level. So then when we print output, right? When we print output, it should be a list of lists. 3, oops, well, we're close to something here, but it's not quite right. So it seems this is not needed. Okay, so we have 3, 9, 20 to 15. It is level traversing, but it's not a list of lists for some reason. So we're getting close to the answer here. Hang on. Okay, we don't need to print the node anymore. So we have our current level. We have our, see, we're appending the node value, right? notice how we're appending the node value, right? The node value. So if we think about it, the whole level needs to be appended first, and then so we have a current level, right? So this is doing one by one, meaning that it's just, I think it's just ordering, that's the problem here. We have our node equals q.pop left, right? We have a current level is this. So I think what needs to happen is this needs to be essentially something like this. So I think, yeah, okay. I think node, have node be what it's, have node be what it should be. Node equals q.pop left. Then append, then do this stuff, right? Well, actually, no, because we're, yeah. So then, okay, it should be something like this. I feel like, okay, this makes sense to me. You can do something like this. I think we're still good for time, 21 minutes. We run the code. No local, oh, of course, because we're saying this. Oh, yes, of course, that's what we need it up there. If I run that now, it's empty. That's because this is being appended, but we're adding no dot value. What we're saying, hang on, I think we're close to the answer. We're close to the answer. It is level traversing. It's just not what I expect as a list of lists, and technically that is a list of lists, but I mean like a level list by list. You know what I mean? So this is the current level. We have our node equals q.pop left. So if this is the node being popped out, right, the current node being popped out, we're saying if node.left, q.append node.left. If node.right, q.append node.right. Maybe, well, maybe we should just add, if root.left, right? Before we even do any of that. So we say if root.right, blah, 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 right? Right? So we add a thing here. I think we do this at the bottom. So we do that. We add our stuff. Now we extract the nodes one by one and then add it to the current level. Or not. Time limit exceeded. Oh my god. Konarayo, bakarayo. Actually, no, I think it makes sense doing it the first way I did it, because we're saying wait a minute. We're saying if node.left, q.append. Node.left. Oh wait, maybe while q node equals q.pop left, if root, or rather if node current level, if node.left, q.append, right? So we have, well, actually, this is our current level, so I think it's going to go here actually. if node, so if node, then the current level is, we don't see, I don't think we should be adding a value here. I feel like it should say if node, right? And then if node dot left, if node dot right, and then we add to the current level, right? And then we output the current level to the thing, no? After doing this. Standard output 3, 9, 20, 15, 7. Still doing the same thing. What's the question again? The question is the average of the levels. The average of the levels. The average of the levels. We have our deck. Q not append left. Let me just say dot append. It makes no difference. We append our root, right? Append our root to the Q. And then we say while Q current level equals node equals pop left. If node dot left, we append the left, we append the right, right? But see, but the current level not append node dot that's just doing it each time. We want to say, oh right, if we have this appended, then it would for loop through the current level, right? So if we're appending, yeah, so if each time, this is our current level, if at every time we appended the value to it, no. Our Q has now 9 and 20 at 1 point, for example. So 9, let's say, that's 3, then that's 9, 20. So if we look at 9, 20, for example, we should say if node dot left, if node dot right, Q dot append, right? But this is doing 1 by 1. So now our Q is all the values. So for I don't know, I and Q, current level dot append node dot val. So for current level node, I'll just call it, nah, forget, I like long variable names. Oh, I think this mic's in the way. Current, yeah, 9, 20, 20, 15, 7. Wait, what? Nah, that's not right. That's not right at all. 9, 20, 9, 20. Then where's this 20? Let's add another 20 for some reason. If node dot left, Q dot append left, Q dot append right. Right? Because it's going the whole way, isn't it? So it needs to happen right here. Right? So something like this. 20, 15, 7. No. It makes sense having it here, right? Because we're saying for current level node in Q, this is what's in the queue at the moment, right? For the current level. So if node dot left, if node dot right, appended, right? Then we say for current level in Q, current level dot append the value, right? 9, 20, 20, 15, 15, 7, 7. For current level in Q, is Q something wrong with Q? Node, if node dot left, Q dot append. It's been 30 minutes. Let me actually hang on. For current level in Q, current level dot append, current level node dot val. Hang on, let me just look at the solution, because I think I've been here looking at it long enough. when did I do this? The 4th of October. Goddamn. Oh shit. Oh, that's what I fucking did, didn't I? I went through what's in the queue first. Oh, so I. Oh fuck. Yeah, that makes sense. If node. Well, actually. So like for I in range Q, length of Q. Oh, I had this in here. So it was, of course, because if you can imagine, we're appending the things at the current level. So we have a current level. We're going through the thing if node dot left, right? So we have our node, and if node has a thing here, we append, right? And then we output to the current. We output that current level. Where outputting current level is. Well, we have current level dot append node dot val. Current level dot append node dot val 3. There we go. That's what I was thinking. So now we have our output, right? Well, we have our output. So now we can say something like for this is our. So we'll call this our BFS, right? Call this our BFS. And then we'll say for, and then we call this our output. So we say for val in BFS output dot append the length of val for val in BFS, for value in BFS. Wait, do I even have the right output here? Divide by 2. Wait, but I don't want that to be a 1 squared though. Wait, 920. 920, the length of it 2 divided by each character. But I don't want it to be, I don't want it to be, oh yes, of course, the sum operator. Oh yeah, they're probably the sum, well, sum them up to divide by the length. Sum of val divided by sum of val divided by the length. Return output. Perfect. However, it's not very memory efficient, is it? Well, I say memory efficient like that would be a problem, but I mean, one's kind of slow though. Is there better solutions out here? Is there better solutions? Python BFS. Pythonic BFS solution. God damn, that's ugly to look at. That is just disgusting to look at. Not even gonna bother. I hate when motherfuckers make shit like that. I just kind of have the same thing here. Ooh, what's this? What does he do here? He goes, he makes a deck and it makes a Q. Alright, does the same thing. Level average. 1 Q. Pop left. If root. See, what makes mine slow is the fact that it has that extra for loop. But how is he doing this without that? If root is none. If root is none, average dot append, double average. Double count. If length of Q dot append, continue, double average. What the fuck is this guy's? Oh my god. Using a marker to decrement levels. What's this? Oh, iterate through each level using its count. It's count, huh? It's count. We iterate over 2 queues with nested while loop. The well-formed by concise speed. Who are interested? Yeah, maybe concise, but what the fuck is this, man? Like, this is not even. Actually, wait, hang on a minute. I hate when motherfuckers in LeetCode write their fucking things in one line like this. Whatever. If root, so we add root while s being the list. Well, like whatever in the queue in this case, I guess. We append to our result. Really, you can't spell the word result. You see RST. Are you fucking joking, my guy? Are you actually joking? I'd fucking downvote you, but I'm not a prick. Fucking hell. Anyway, we append the sum of the value. So see for, oh, either way, you're gonna have this for loop. So for node in S divided by the length. So we're just doing it as we go without the extra thing. And then we're saying for node in S. So we're saying, well, sorry, we're saying for n in left and right if n, of course. That's interesting. That's an interesting way to actually do it. I didn't think, that's interesting. Didn't know you could do that. Didn't know you could just like for loop through the thing like that. Just say for, you know, in this and that. And if n, so left and then it's right. So for example, and then for node in S. So S is the list. And now we're saying for node in S. Sorry, we're saying for okay, n is node left. Node left, right? And then for node in S. For node in S. So what's in S at the moment? Whatever it is in the moment, then n. Iteration. BFS row-wise, BFS pairwise. Row-wise, pairwise. What does he do here? While Q node equals node in dep. What the fuck is dep? Equals Q dot pop left. What the fuck is dep? Does pop left return 2 things? Python dec pop. What does pop left return? Pop left. What the fuck? Does it return 2 things here? Pop left. Where's the Python docs? Pop left says, okay, what pop left take it? Remove and return the left side. If not, it's a person raising an index error. So what the fuck is he doing here? Pop left, D not pop left. What the fuck is he taking in? Node equals Q not pop. Whatever, I think my solution is good. You know, actually, interestingly enough, yeah, I want to go back yesterday, look at path sum without the recursion. I want to go look at a non-recursive solution to that actually, because I don't know, I want to see like, because I never looked at the iter version of DFS. Like, yeah, cool, nice recursion and all that, but then it's like, I don't know, some questions are just easier to solve in recursive fashion. But hang on, I'm trying to see an iterative solution here. All right, let's see. DFS with stack. All right. Oh, okay. If not root stack equals root val. So okay, we got some tuples going on. Oh, it's kind of what I just did for the BFS, isn't it? Oh, I see. The only difference is that mine would have the for loop to go through each level. Oh, so you can tackle it the same way. The thing is, I mean, would they be mad that? Because if I find iterative to be better, because it's like, I mean, I don't know. I'd find the iterative to probably be better. Hang on. Let's see. Let's see. So interestingly enough, you can just recursively do the exact same shit. To be honest, I probably understand this more because if you look at it, we're saying obviously if not current, da da da, and value equals sum, return true. If the current dot right, if current dot right, actually it's a bit different because over current over value. Wait, what the fuck is going on here? Oh no, yeah. If not current dot left and not current dot right, and the value equals sum, return true. If current, oh yeah, of course we have a stack. We have a stack, right? Where we have our current node. You should really call this node, dude. Like what the fuck? Anyway, we have a current node and there's value. If the blah blah blah. So if the node dot right, node dot left. If node dot right, then append the right node and its increment its value. We're adding its sum to the right side, then adding the sum to the left side. So we're adding the value to the left side to the current value, right? So we basically have a stack building up our thing. Interesting. Half of the Google questions can be solved using DFS/BFS. Yeah, I think that's why it's important to learn it. Yeah, I think that's why it's important that I focus the next maybe 2-3 weeks on this, because I'm assuming this is Google's loves these kind of questions. We got 43 minutes. Def pass path. If not root, walk Q. So interestingly, I see. This is BFS with Q. BFS with Q. What's a has path sum is just that there's a path exists, right? Yeah. And then the DFS method makes sense. I mean, we have a stack essentially. So I mean, I'm just trying to understand what he's doing here. So we have a stack, right, of whatever value, and then recurrent pop, blah blah blah. So if the current, so it's kind of similar, yeah, similar to what I just did for the thing. If current dot right stack dot append, he appends the right node, appends the right node, and appends the right node's value, right? This is the current thing in the stack. We pop the stack, right, and then we ask ourselves if the current node, right, if we're at a point where the current node is whatever. Remember that we start off with the initial value. So if I actually compare, if I actually go to this question, I just want to duplicate the tab and let me just check out the actual example so I can compare description. So we have, this is the example, 5, 4, 11, 7, 12, 18, 13, 4. Honestly, like, it's probably better to write things iteratively because you can see the exact flow of shit. I don't say the reason to ever use a stack, if I'm being honest with you. I mean, use a recursion, if I'm being honest with you. It's just fucking bullshit. But hang on, I'll leave it. Sometimes I guess it's easier. It's just simpler code, I guess, if you get it. But hang on for a second. Because obviously, look at this. This is a lot shorter than this, right? But we have 5, 4, 11. So for example, we have 5, right? We have 5. We have our current value. So we have 5 gets added to the top, right? Because it's, you know, the top thing in the list. We have 5. And then we say while stack, right? The current value is 5. We ask ourselves, does the current node have a left and a right? It does. It does have it. This is not valid because there is left and right here. So we add the right because 5 has 8 and 4. So we add 8, we add 4. So now we have a stack that has, so this would be a pre-order traversal. Sorry, this would be a, well, he's adding the right first, but remember a stack is first in, last in, first out. So that means that when we add right to the top, when we add 8, yeah, we add the root first, right? The root being 5 to the stack, right? So we have, so this is an in order traversal, right? Or is it? Well, let's see. We add right, then we add left. But as you can imagine, a stack is, obviously if you imagine it, we add 8 and then we add 5. So of course we have what gets popped out here is 5 and then 8 in that order. And obviously we added the root first originally, which was, oh sorry, 8 and 4. So we have 5, 4, 8, 5, 4, 8. This is a pre-order traversal, right? Pre-order traversal. This pre-order traversal, right? Where we go root thing, then, oh yeah, that makes sense. So we add our thing, all right? So now this is what's in our stack, 4, 5, 8, right? 4, 5, 8. And we, yeah, okay, yeah, we go cool, but we keep adding them to it. But remember, this is DFS, so we're not for looping levels by levels, so we literally add the whole stack in that fashion. So basically, we go, actually, yeah, no, I'm interested. I'm going to draw this out. So we have 5, 4, 11, 7. 5, 4, 11, 7, right? So we add the root. We then go, oops, we add our root. We add the right value, right? We add the right value to the stack. We add the right value to the stack. We add 8. We add 4. Well, no, actually. Because we're saying if right, append right. While stack, remember. And then if left, append left. Oh yeah, if left, append left. So 4. Oh wait, this value is 5. Okay, but this has it. But then now we're asking ourselves when we pop out. Yeah, but then now we're asking ourselves when we pop out 4, right? When we pop out 4, well, actually no, we pop it out initially, don't we? Yeah, we do. While stack. So before we even append, we've already popped out 5. So 5's already been popped out, right? It has a left and a right. That being 4 being the left, 8 being the right, right? However, we are at right. Remember the rights. If right is valid, we add right. If left is valid, we add right. So we have, so our stack currently is 8 and 4, right? Our stack currently is This is currently our stack, right? 8 and 4. Our stack is currently 8 and 4, right? We pen right, we pen left, while stack, right? So we go now to, we pop out 4, right? We pop out 4, but we also check that 4's left and right. What's 4's left and right? It has 11. So we pop 4 out. So we pop, well, actually it's already drawn anyway. We pop 4 out, and then we got 11, right? We then pop 11 out. Oh my days. Fuck it out. Let me drag the fucking bullshit. Let me drag this fucking shit. You let me. Oh my god, mate. Let me drag it. My fucking. Let me drag this fucking. You fucking bitch. Let me fucking drag this thing. Jesus fucking Christ. Oh my. Okay, here. Fucking one at a time, you fucking cunt. Alright. Fuck hell, you twat. Still my fucking head. Fucking hell, mate. Pissing me off, you are. Wait. Oh yeah, sorry. We also not only. Oh, that's right. We're penning a fucking tuple. I'm drawing this out on paper. Fuck that auto draw bullshit. Fuck that auto draw bullshit. Each time we append the value plus its current value. Alright, so we have 5, 4, 8. 5, 4, and 8. We have 5, 4, and 8. So the initial value, right? So we add this to our stack. We add 5 to the stack. We pop it out. We pop that bitch out, right? But we see that it has a left and right, so we add 8 and 4 to that. So now we have the value 5, right? But when we append 4 and when we append 8 and 4, we're not just doing that. See, we appended 5, yes, but remember it has a left and a right. The 8 that was appended, right? So now we have the current value, right? The current value. So now we have 5 plus the right value. So now we have 13, right? We have 13 over here. So we have 13 added. Then we have 4 plus 5. We have 9, right? So now we have 13 and 9 in the stack. We have our 5 value, right? Which, was just doing its thing. Cool. Then we go to 9, right? Which was the node 4, which was this node, right? And this was node 8. We then go and take the value, right? We take out the left and right of 4, which is just 11. We add 11 to the top. Now we say 9 plus 11 is 21. We have 21, right? Well, 21 being the left. 21 is added to the stack. We have 21. Its node is 11. We have then this in the stack. We see 21. This if condition is still not true. We then go to, so now on top of the stack is node 11. Node 11, so we have as a 7 and 2. So we append 2, we append 7. 2 plus 21 is 23. 2 plus 21 plus 7 is 29. So now we reach a point where we have right is appended first. Yes, right is appended, then left is appended. So we have left. So we have left. So now 7 and 21 are on the top. 7 and 21 are on the top. We pop that out. It satisfies this part because it has no right and left. However, its value doesn't equal the sum. So that just popped out. This doesn't go true because obviously, you know, that's not valid anymore. We're at a leaf node. Then we go to current dot val again. We now have 23. 23 equals 20. Sorry, 20. Wait, what? 21 plus. What's the bottom of this stack? 21 plus 2. Oh, sorry. That was. Initially, we're at 5. Then 4 was 9. Then 9 plus. Then 9 plus. Oh, sorry. 9 plus 11 is 20. Oh, fuck. The fuck was I doing? 20 and then 20 plus 2. Oh, yeah. Pretty solid solution. Pretty solid solution. We had a tuple of the node and its value. Go down through it in a well, this is added first in this, so it's a when the node is done first. So this is a pre-order traversal. Makes sense. Not bad at all. Not bad at all. And just like the comments said, you can answer half of Google's interview questions with BVS and DFS. I kind of see why they ask these type of questions. You know, kind of makes you whatever. I was wondering where these people go. You know, after they do all these questions, like what they do, but. Yeah, it's pretty good. I'm gonna leave this video here with this. I think I learned. I think I kind of got. I'm happy with today. You know, I almost got the solution on my own completely, and I understood. I understood the intuition. I then went back to an old question and understood how to do it in a different manner. Might even be the manner I continually do it in. So we'll see. We'll see. I'm gonna go after this and watch this. There's a video by SEW Engineering. No, what's his name on YouTube? What's his name on YouTube actually? His name is the fuck's his name again? Something engineering. Oh, there we go. Back to back. Funny thing, fuck the video. Is this a recommended page? Lol, this is the exact video I'm even looking for actually. It basically explains the whole thing. I think I'll go over this again. But yeah, I think to be honest, I think I understand how to do it iteratively more than I do how to do it recursively. And I think I'm going to keep trying to do them iteratively rather than recursively. There's no real benefit, honestly, doing either or. I think just pick one, because if you think about it, when you're iteratively doing these questions, you're still building a stack, right? You're still building a stack that you're popping from, or a queue that you're popping from. With recursion, you know, you're building the stack frame. You know, there's obviously the stack as you can make on your own, but then there's the actual stack frame of when you're doing recursion, right? That stack in memory is well, actually, to be honest, I want to know a more technical definition. I know the kind of a black box definition of it, but hang on. The stack versus the recursive stack versus a stack or something like that. Recursion versus stack implementation. Yes, versus explicit stacks. Actually, this is like a whole article, isn't it? Oh no, sort of. The other day I was trying to solve a problem related to tree structure data. Usually most of the solutions of problems are recursive in nature. Recursion involves implicit stacks. This is implemented in the background by compiler using your compiled code. The background is created by compiler. Oh yeah, sorry. Yeah, the call stack is what I was referring to, of course. This background check. Okay, blah, blah, blah. Each function in subroutine calls use a frame. Okay, blah, 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 inside the stack frame. Yeah, the call stack. That was what I was looking for. The call stack. In computer science, the call stack is a stack data structure that stores information about the active subroutines of the program. This kind of stack is also known as the execution stack, program stack, control, runtime machine, or just the stack. Yeah, that's cool. All right. Cool. I'm going to go watch this after this video. Come back later in the night, do another BFS, DFS question as usual. Call it a day. Talk to you later.